Welcome back for the second lecture of Information and Interaction Design. Today we'll be talking about user experience or UX design life cycles. So when we talk about the UX design life cycle, we're referring to the process of both creating design ideas, also representing them clearly. And we usually do that through prototypes, whether it's sketches, wireframes, or hi-fi prototypes. And for software, that usually means that you're designing interactive interfaces. And for physical products, it might involve shaping the form factor or the structure of the products. And as UX designers, the prototypes is typically where we stop. But it's important to remember that our designs will be realized, meaning they'll be turned into actual products by software developers or engineers. And so it's important to understand their design life cycles as well and how UX fits into the process. So let's back up a little. What are design life cycles? Because at their core, life cycles are about the process. And why do we need process when designing something? Well, a well-designed process provides a guiding structure or framework to keep designers on track. And it helps answer key questions like, where are we now, or what should we do next? And you'll find that documentation is a big part of that process, because the record that we keep can help designers look back and learn from their own or other people's efforts, and also to figure out what worked well and what didn't. And that's going to improve the design process in the future. So you might have seen these life cycles in computing in other courses, so we'll just do a quick review here. So in the early days of computing software, people used the Wild West approach. It's pretty much just code and then fix the bugs, code some more, run, and fix new bugs. So there really wasn't much strategy to it. And that worked okay for small projects. But it doesn't work so well for larger teams or complex systems because bugs become harder to trace and fix without breaking something else in the code. Also, it's hard to estimate how long a project is going to take or how much it'll cost. So more structured approach was needed as systems grew in complexity. And that led to the development of the waterfall model. The waterfall model is one of the earliest and most well-known life cycle models. So, as you can see here, it consists of a sequence of stages that flows downhill like a waterfall, thus the name. Also, we can't move backwards to a previous stage in this model once you've reached the next stage. And that means that each phase has to be executed completely before moving on and beginning the next phase. And each stage results in a concrete product, whether that's a requirements document or a set of designs that feeds into the next stage. And each stage also includes its own validation based on requirements from the previous stage. For example, let's say that the resulting product here, in the detailed design phase was a set of unit tests. Then the code that was developed in the next phase, coding and unit testing, is going to be validated against those unit tests. There are many advantages to the waterfall model, especially when compared to the code and fixed model. So, first of all, it's so easy to understand, it's so easy to use and implement, and that it has stages that allow for go, no-go decisions. And it has a large emphasis on documentation. And we talked about why that's useful. So this approach is good for well-understood, established products where quality is more important than the cost. Because the waterfall model is widely used for government projects and for many safety critical systems, such as those used around NASA or healthcare or air traffic control. But it does come with some disadvantages as well. First, we have to define all of the requirements up front, all because this model is not flexible. Think of it like steering a big cruise ship. Once it's in motion, changing the direction is slow and difficult. And similarly, it's hard to add new features or come up with new ideas mid-flow when we're already using the waterfall model because changes are costly and they require many meetings and approvals. And another disadvantage is that users aren't involved in the process until the testing at the very end. Another well-known model is the Agile model, which is a combination of incremental and iterative process models. And that means instead of just delivering one big final product at the end, Agile teams deliver smaller working pieces more frequently and adjust them based on feedback. And the main advantage of the Agile approach is that it's very flexible and adaptable, so that's the main difference compared to the Waterfall model. Because in Agile, work is done in short iterative cycles called sprints. And each sprint lasts about 2 weeks and is focused on a specific feature or a set of related features. And at the end of each sprint, something tangible is delivered to the customer or stakeholder, like a working feature or a prototype or a product update. And customers can modify the requirements during the project based on what they see. And that often leads to higher customer satisfaction because they could give feedback whenever they see something that's not appropriate, or maybe they have an idea, or maybe they say like, oh, here's something I'd like to see in the product. And we can test that out during the next sprint. There are some downsides to the Agile approach. So first of all, there can be confusion about the process because there are so many types or variants of the Agile model, like Scrum or Kanban. And many companies use the approach because it's trendy, but they don't spend a lot of resources to establish the process or to even educate the employees about it. And also, the outcome totally depends on the customer interaction. So if the customer is not clear about their own requirements, then the development team can go totally in the wrong direction. And lastly, Agile often emphasizes working software over comprehensive documentation, and that can be problematic for projects or industries that require extensive documentation for compliance or for onboarding. So we've looked at a couple computing life cycles, and in the early days of computing, the primary focus was always on the functionality and the capabilities of the hardware and the software. Usability was treated as a last-minute add-on. The mindset really was build the feature first, and if we can make it more usable, then even better. And that approach made sense at the time when computers were mostly used by scientists and engineers with specialized training. But as the early 1980s rolled around, usability became more important with the rise of personal computers. And by the 1980s and 90s, people were really calling for more formal process for the usability aspects as well. So with that as background, we'll start looking at the UX lifecycle in the next video.